All right. So besides the moons of Jupiter, which by the way Galileo called moons, um, these four bright moons of Jupiter, he also using his primitive telescope looked up at the Milky Way. Now you can see the Milky Way. Um, it kind of looks like a hazy, almost cloudy looking um, patch of sky, and it's always in the same locations throughout the sky with respect to the stars. It moves along with the stars. Um, but when he turned his telescope to the Milky Way, he saw that there were unbelievable numbers of stars. Um, and um, it began humans questioning whether the Earth is actually the center of the universe. I mean, that starts. It begins. I mean, this is not like the all of a sudden there's this huge shift in human thinking, but it begins us thinking about our place in the universe. Copernicus really makes the big step where before Copernicus, because of Aristotle, the Earth is the center of the universe, and then for Copernicus, our sun is the center of the universe. With this observation, this begins some people to start thinking about where is the sun in the universe, right? So that's what this is about. It um, doesn't tell you really anything. That there's a bunch of stars in the Milky Way. It just people start to think, okay, where are we? All right. So it takes a while actually before people even accept, that is the human species starts to accept the fact that the sun is a star just like the other stars. In fact, we find out that stars are very different from each other. They're not all the same. All right. All right. Getting back to the time of Galileo, one of the things that completely shows that the sun that that the the sun centered solar system is correct, right? The heliocentric model is correct over the geocentric model, is one of the observations that you can only do with the telescope. So Galileo looks at Venus and he observes that Venus is undergoing phases, right? That is one of the things that um, the fact that Venus is undergoing phase, and Venus's orbit around the sun um, is much less than a year. Uh, Mercury's is about um, you know I think it's like 3 months, so it's less than 100 days. Venus it's I forget exactly what it is. But it's more than 100 days, and actually I think it's closer to 200 days. But you during that time you can sit there and watch the phases of Venus, and the geocentric model doesn't work. Like that's what they're showing you over here. Is with the geocentric model, you're not going to get all the phases of Venus that is observed. The gibbous phase and the crescent phase. That only occurs if Venus is going around the sun, which of course it is in the Greek, the original Greek model, right? All the planets are going around the geocentric model, I guess I should say. All the planets are going around the Earth, and of course they're traveling in these little epicycles according to Ptolemy. But that still won't get you phases, right? That won't get you the phases that Galileo observed. Let's see. So Galileo lives a little more than 400 years ago. He's a contemporary of Kepler. Um, he is the one who's credited with inventing the scientific, the experimental part of the scientific method, the thing that we now use in the modern, the full scientific method, right? I mean, the Greeks had their own version of the scientific method. They rarely used experimentation. In fact, Aristotle actually argues against it and just says the human mind is so powerful that you don't really need to experiment, which is kind of, that's not true at all. We absolutely need to perform experiments. To some extent, Kepler performed experiments, not directly. He used experimental evidence, that is, measurements that were made on, by Tycho Brahe on Mars, and came up with his laws of planetary motion. So Kepler also did this as well, but Galileo is the one that's given credit. He actually comes up with the first law of motion. It's also known as the law of inertia. We'll cover that more in the next chapter, chapter 3. I'll just briefly go over that one. That's the one that an object at rest will stay at rest. An object in motion will stay in motion unless acted upon by an outside force. So that's called the first law of motion. All right. Anyhow, so this is kind of a tragic part of Galileo's life. Let's see, what's the, oh yeah, then we go to Newton. All right, so let me briefly go over this with Galileo. All right, so Galileo writes a book about his telescopic observations. It's called The Starry Messenger. Becomes a absolute bestseller all across. I mean, it's translated into other languages and so forth. And the thing that he does, which was not something that you did back then, 400 years ago, is he wrote the book, The Starry Messenger, in common Italian, right? Whereas the language, if you were going to write something scholarly, right, you were supposed to write it in Latin. And only, the people who could read Latin were, the comparatively very few educated people. The clergy, priests could read Latin, doctors could read Latin, and pretty much lawyers could read Latin, right? Those were the main jobs for people who could read Latin. So by him writing this Starry Messenger in Italian, in common Italian, for the common person to read, he kind of he went against the system, and not just that. Galileo, he was one of these. He was very. He was a genius. I mean, there's no doubt in anyone's mind that Galileo was a brilliant, brilliant individual. But here was the problem. Here's the problem with Galileo. He was brilliant. He was going to let you know he was brilliant, and he was going to let everybody around him know that he was brilliant. So he discusses with this cardinal in the Roman Catholic Church, a very prominent cardinal, which is a high position in the Roman Catholic Church, about he has this intellectual discussion with this guy about the geocentric model versus the Copernican model, right? Remember Copernicus had been around for 100 years or so before Galileo, and so the Copernican ideas were out there; they just weren't accepted. So by people like Kepler and Galileo, of course, they accepted it. They knew that the Copernican model was the more accurate model. But the geocentric model was still lingering around. So anyhow, he makes this argument with this particular cardinal who was very prominent in the Roman Catholic Church, and he writes a different. So this is a different book that he writes. He writes this other book, and in the book he uses what's called the Socratic method. A very, it's posing questions and then coming up with answers, posing questions. And so he has kind of the same discussion that he had in real life with this cardinal in the book. But the person in the book who basically kind of takes on the role of the cardinal, Galileo calls, I forget, like Simplicico or something like that, like the simpleton, basically. I mean, now Galileo's not a stupid person, so in his book he lets Simplicico win the argument in the book, right? But anybody who reads the book knows that Galileo's argument is much, much more powerful than Simplicico. And, well, it turns out that the guy who, Simplicico is based on, who was a Roman Catholic cardinal, becomes the Pope. Okay, so now that's the highest position in the Roman Catholic Church, and he reads this book and does not appreciate this discussion that he thought was a private discussion between him and Galileo, being written as a text, as a book. So Galileo is called to Rome by the Inquisition. All right, so that's the Inquisition was just a horrible branch of the Roman Catholic Church. They tortured people, they killed people for heresy, basically. For if you went against the teachings of the church, you were deemed a heretic, and you sometimes were punished by death. Torture was definitely part of it. All right, so Galileo's brought to Rome before his old buddy, I use in quotes, buddy, the former cardinal who is now the Pope, and he's told to basically say that the geocentric model is correct. The model for some, that's the other thing. For some reason, the church has adopted Aristotle's idea of the geocentric model, and they adopted it big time, right? Like there was no going against Aristotle, and Galileo had argued against Aristotle, and that was a big thing that could be interpreted as heresy, and so Galileo was forced to to state publicly that was wrong. And in fact, he got as far in the Inquisition as they lay out these instruments of torture in front of you, and they say, basically, well, if you don't say these things that we want you to say, we're going to torture you. And Galileo, being a scientist and a very smart guy, he was like, oh yeah, no, I'm not going to be tortured. You want me to say the sun goes the sun goes around the earth? Absolutely, the sun goes around the earth. And he was put under house arrest, and for the last 10 years of his life, he lived in his villa in Florence, Italy, and he actually went blind, as I mentioned before, by because looking at the sun is a bad idea.